Thank you, Alec, for that wonderful introduction. And I'd also like to thank Anna for helping pave our way here, and Oleg for getting my visa lined up, which was quite an adventure, and others at the center and university for facilitating this. Also, the work I'm talking about relies on research of other people, like all research does, but particularly it relies on work by a advanced graduate student who is finishing in about a week at Cornell, Catherine de Ritter-Vignon. She and I have actually co-authored a paper that uses some of the material I'll be talking about today in a journal called Leonardo. And also a former student, Cyrus Modi, who is now at Rice University, helped tutor me both in nanotechnology and in the history of nanotechnology, which is his specialty, and I'm relying heavily on that. So I'll be talking about imaging, and am I in the way of that? No, I'm not. Good. Imaging in nanotechnoscience, we can call it, because nanoscience, like biotechnology, is very closely wedded between the science and the engineering side of it. So it's popular in science and technology studies to speak of technoscience. It's not a term I particularly like, but I think it really fits with nanotechnoscience. I'll give a little bit of background on that, and then I'll try to relate it to the theme of the next couple of days, which is innovation and entrepreneurship, which is not what I set out to do when I did this research, but I think there may be some connections, and we can perhaps discuss some of these after the talk today, or perhaps for those of you participating in the meetings further on. But two basic features of nanoscience, nanotechnology, if you're not familiar with the field, are that there's an issue of scale. 1 to 100 nanometers is usually considered the range at which nanotechnological research operates. A nanometer is 1/billionth of a meter. That's very small. It's unimaginably small. And so it's within that range. Now, you'll see that that range is used rather loosely in nanoscience, nanotechnology. Often things larger than that will be folded into the field, partly because of its current popularity and promotion. A second feature is that it's not only about visualizing or studying things at that level, it's about manipulating them, making things, moving things around, rearranging things, so that it's an engineering discipline as well as a discipline of research that tries to discover what is available at that level. So why is it of interest in this meeting? Well, one theme that runs through a lot of the social science research on nanoscience and nanotechnology is that it's very future-oriented. In the United States, as in other countries, there were large government initiatives to get started the movement in the 1980s, 90s, and through the early parts of this century. Influxes of money, particularly from the NSF in the National Science Foundation of the United States, and their parallel programs in other countries, to imagine a future in which very useful innovations are produced at the nanoscale, and that would involve multiple disciplines collaborating with one another. So convergence of disciplines, the tying together of science and technology, so that the distinction between basic and applied science is very hard to tease out of that arrangement. And also commercial involvement, such as had already been developed in the biosciences, in particularly genetic engineering and biotechnology. And to some extent it was modeled after biotechnology, although they want to avoid some of the problems that biotechnology ran into with the genetically modified foods in Europe and Japan and some other places. So there's been a lot of efforts to assess the public reaction to nano. And for the most part, the public is unaware of nano. When you dial up nano on Google, you will get a car in India or an Apple product that came out under that name. Now I'm going to talk about one aspect of this sort of future orientation in nanotechnology that involves images. There's a kind of I don't think it's actually a paradox, but there's an interesting juxtaposition that most people who define phenomena at the level of the nanoscale will tell you that these phenomena are not only invisible because they're too small to see, but that they are smaller than a wavelength of light. They are at a level of scale at which quantum forces are very powerfully part of their composition. And so they defy our common sense of what an object is. You know, an object that would be stable, well-bounded, that we could depict as lighted and shadowed. These sorts of features of macroscale or even microscale objects apparently do not apply to nanoscale objects. And so they're considered different, essentially, from what we tend to be familiar with in everyday life. Nevertheless, images are ubiquitous, both in the research and in the promotion of nanotechnology. I'll be talking mainly about the more popularized images, partly because I'm not a chemist or a physicist, and getting access to what's done with some of the research objects is quite a task that would take years to master. But some of the more popularized images I think we can get hold of and have some things to say about. So that we'll be looking at images that are primarily involved in the promotion, the popularization, and also kind of playfulness, artistic playfulness that's associated with the production and dissemination of these images and of nanoscale or near nanoscale objects. So this is perhaps the most ubiquitously circulated nanoscale image. Oh, yeah. For some reason it's not coming out with the color of the original, but this was an award-winning artistic rendering. It is not an image taken with the microscope, but it's an imagining of something that the artist called nano louse. You know what a louse is. It's not something you want to have in your hair. It is looks like it's made out of a plastic type of medium latching onto a blood cell and either injecting that blood cell with something to heal it or sucking something out of it that might kill it. I'm not sure which, but this is a type of image. I'll return to this later in the talk. That is very early in the history of nanotechnology in the early 1980s and late 1980s was a type of image that proliferated. And you can see that if you didn't know this was a photograph, you might think, is it a photograph? But it's actually in some ways more perfect than a photograph. There's no interfering particles in the plasma. Everything seems smooth and kind of perfected in this picture, so I'm calling it hyperrealist in its depiction. We'll see that imagination, such as in this sort of free fantasy imagination in this picture, comes into play in lots of images in nano, and the depiction and the imagination is often future-oriented and promotionally oriented, portraying possibilities that at least some people think nano could catch up to. Now, what I want to do is to look at how imagination features in a variety of different types of nano image and to examine how the artists and the scientists who make these images deploy imagination differently. You probably can't read this very easily, but it's a text that's very important for the history of nanotechnology. It was written in the early 50s. It was actually a speech by the Nobel Prize-winning physicist Richard Feynman, who also became a kind of popular writer when he wrote about his career. The reason it's hard to read is that this was inscribed through a technique called dip pen lithography. Now, you don't need to read it. I'll summarize what it's a very famous speech. You can get it online, where Feynman, early in the 50s, argued that there will be a possible future in which science will devise machines, will devise modes of writing that are many, many, many times smaller than anything previously done. The speech was entitled, "There is Plenty of Room at the Bottom," bottom meaning the scale, below the scale of what's visible or even available through microscopy. And here he talks about you could write the Lord's Prayer on the head of a pin, but he even imagined doing engineering at a much smaller scale than that. And that speech was later picked up as kind of a precursor to what in the 1980s started to be called nanotechnology. He didn't use that term himself, but this is often used as kind of a watershed moment. I'm showing it because it ironically has been itself inscribed, not at the nanoscale, but pretty close to it. This is a 400 nanometer space here, so it's a bit larger than that, but it's a kind of a demonstration of that. To give you an idea of what's involved in some nanoscale research, it's a very broad field involving lots of different fields and types of instruments, but the instruments are very important, and the person I mentioned earlier, that my former student Cyrus Modi, has just recently published a book on the history of the scanning probe microscope and other related types of microscope, and they're very important for the kind of research that's done in a lot of nanoscale research. What I'm doing here is giving you a schematic of optical microscopy, optical vision as it's often portrayed, where you have an arrangement of lenses, whether it's the makeup of the eye or the old-fashioned light microscope, and there are image-object relationships. Often the idea is to get a correspondence between image and object without distortion, right? So it's almost like a philosophical instrument that is associated with the correspondence theory of reality, where there's a clear separation of object. The attempt is to envision the object through refracted and reflected light, and to, in various ways, project an image onto paper or onto the back of the eye. The types of image used, or types of microscope used in nanoscale research is quite different. Cyrus Modi says that there's at least 50 patented types of microscope. One type broad type that I'll talk about is the scanning tunneling microscope, which operates very differently. This is a picture of one variety of one. It's ultra-high vacuum scanning tunneling microscope, in which the chamber is evacuated, specimens are put into it, different arrangements of very cold temperature to slow it down and to keep interfering substances out of the air are used to visualize things. There's many others. The atomic force microscope, which is featured in the book by Lorraine Daston and Peter Gallison called Objectivity, is somewhat similar to this in the way it operates. It's said that the scanning tunneling microscope, I'll call that the STM for short, allowed for the first visualization of individual atoms. That's doubtful. because there are other devices earlier than that that allowed for the visualization of atoms. And the question of what it means to visualize atoms is an open question, as I'll try to demonstrate. So the way this would be an example of a crystal of silicon called the 1117 by 7. We won't go into what that means, but it's a particular configuration of the surface of a crystal that's been fractured. And it's not coming through very well in this slide, but you can see these circular things would be images that would be associated with atoms arranged in a crystalline structure, and then the effort is to try to unpack that arrangement through the analysis of the different atoms. Visualizing atoms involves more than just looking at stuff with a microscope, and it's not even looking. It involves calculations, synthesis, the use of simulations and models, and various instruments and practical abilities to use them that bring together various forms of data to produce what's arguably an image of atoms. What we'll see with the STM is it's not only a visualization tool, it's also a manipulation tool. And in this schematic from Don Eigler's website, you can see, especially if you look at this part here, the probe microscopes are indeed, they operate like a probe. They operate like a stick that, say, a blind person would be using to feel the pathway in front of him or her. The tip of the probe, though, doesn't touch an object, and you don't feel the object. Instead, a current is run between the object, and the amount of current is a measure that can be converted into a measure of distance as well as a measure of different types of potential. So it's operating on a very different principle than the light microscope, or even the transmission electron microscope, which projects light reflecting off of an object, or in the case of the electron microscope, through the object to make a shadowing effect. This is instead a very, very chemically sharpened tip that runs over a surface, or runs at a distance from a surface, and uses current to measure electrical potential. And then with various programming feats and scanning patterns, you can develop an image of a topography. Now, the thing that this is showing, however, is not only visualizing a surface, but manipulating the, what happened here? Just say no. Here? Yeah. Just say no. Okay, good. It's moving stuff as well as visualizing stuff. And that possibility of moving and manipulating was very early on in nanotechnology used as a demonstration tool and a possible mode of technology. So when you have it as a scanning visualization tool, programming is used to convert a pattern of measurements in a scan to, first of all, a two-dimensional array of pixelated measurements, and then that can be drawn out into various three-dimensional arrangements, such as these peaks, and then color coding can be used to provide different types of gradients or separating different levels of intensity for the peak, so that it becomes, like in this last one, a snow-capped mountain. So there's various formula for converting an atom to something that does look like a peak, and one of the best known, most often reproduced series of articles of images comes out of a laboratory at IBM in the late 1980s that produced a series of images that are still on a website for the IBM Almaden laboratory that demonstrates what can be done with a probe microscope. And so the famous IBM image was produced by moving xenon atoms on a base. And then Eigler and his associates produced what they call quantum corrals, arrangements of iron atoms on a matrix that set up their own wave patterns once they're arranged in a circular arrangement here. And this image shows sort of a time lapse of the assembly of the quantum corral, and then a rather spectacular image of it taken from a side. This particular image is quite interesting as a reconstruction of a nano image, in that you can see it is as if it is illuminated. These peaks are illuminated from the side. The wave pattern in the middle is discretely pictured as a surface, as if it was lava or water with a very strange color. And and so that it looks like something where the viewer is peering over the edge of, say, a crater into this pool of lava, and it looks like a macro scale object, right? It looks like something you would see in a landscape. And this type of conventions of depicting a level of reality, if you want to call it that, that is essentially beyond the touch of light, is nonetheless using classic types of shadow effects from linear perspective to produce this kind of arrangement. Questions arise, particularly among philosophers, about whether this is an okay thing to do. Actually, Chris Robinson is a nanoscientist and artist, but he too raises these kinds of questions about, you could call it the ethics of nanoscale imaging. Of concern are images like this cover of Scientific American 12 years ago, where, again, it's not too visible with the lighting here, but it's a cover illustration for a special issue about molecular electronics, the idea that you could have a new kind of electronic junction where an organic molecule or some other type of molecule would be an intermediary between two metallic electrodes. And so a space-filling model here, looking like billiard balls packed together, the kinds of things that you might play with if you had a chemistry kit to model chemical structures, is shown between two gold, perhaps bronze, hammered surfaces. And it's done in a very realistic fashion. You can't see it too well, but there's even a background that indicates a kind of a organic matrix behind it. And yet, the thing is completely a construction. It's a model. And this kind of conflation of model features where you have, light reflecting off the thing with all these macro scale features to depict something that's both hypothetical and existing at a scale in which you would not see hard, bounded, color-coded atoms disturbs some analysts of this technology. So the quote I've taken from Robinson is that he's concerned that scientists trying to interest the public, either in magazine covers or, say, online images, will often do things with images that perhaps are productive for research dollars, but which give a very inaccurate picture, in his view, of what is at stake, what is involved when you work with the nanoscale reality. And that is a theme that runs through a lot of it, commentary on this. Joseph Pitt, who's a philosopher at South Carolina, also raises similar concerns where he worries that this kind of depiction, this was a popular promotion image of nanotechnology where you see, again, peak-like atoms arranged as if it was a moonscape, right? And then outer space stuff put in the background just to give it color. And then this slogan of shaping the world atom by atom, promoting this idea of a new order of technology, would be so far from what is actually being done or could be done at that scale with foreseeable technology that it's going to create distrust in the field, right? And so he says, he talks about how these depictions show fields that we can manipulate at will, twirl them, enlarge and narrow them, put them to music, make them dance, when in fact nothing of the kind is the case. The world at the nano and quantum mechanical level is a buzzing, shifting, constantly in motion in non-linear and non-classical causal fashion, whereas this depiction is quite classical in terms of lighting effects, shadow effects, macro scale background imagery. To use a term, Oleg mentioned Harold Garfinkel, who was my teacher when I was in graduate school. He's famous for the slogan, making the familiar strange by disrupting ordinary kinds of routines in conversation, in face-to-face behavior. They're all lots of fun, sometimes rather horrifying to practice these things. But this is the inversion of that. It's making the strange familiar. So when we go back to this slide here, these kinds of depictions are taking something that, at least in theory, is not computable in our ordinary sense of things or what a thing is, and turning them into macro scale forms, macro scale models and objects. So it's doing the opposite, taking something that is said to be intrinsically strange and making it look familiar as a way to convey it to people who are novices in a field. And sometimes it's depicting things in a way that it depicts what they should look like, even if they don't look like that. Many familiar visual conventions from art history are used to do that work. So what Catherine Vignoni and I did is we went through image galleries. Now, of course, the term gallery is a term familiar to art. You expect to see private galleries selling art or museums with, thematic selections of, art from a particular period or place. Image galleries have proliferated in a number of fields. Astronomy has quite a few, planetary science, various natural historical types of investigations, and above all, nano has lots of them. They're quite heterogeneous. Some of them are simply put together by people who pull a bunch of images together, find them interesting, and put them on a website. The best known and one of the oldest is the one I mentioned earlier by Don Eigler, who actually does produce these images with his associates, or he did until he retired at IBM. And I'll be talking about some of the particulars, and that's just the facing page of it if you were to open it up on the web. And it's designed like a gallery. His is rather unique. He actually has a layout of rooms as if you were in an art gallery, and you go into different rooms, and one of them is called the Blue Room and so forth. You can go walk through those. We went through these. Some of them are contest winners. Various companies and various other organizations hold contests for best image of a certain type, and the winners are then exhibited on a gallery website. We find these images interesting as a basis for investigating the different types of image that are associated with nano. We learned to appreciate that it's not all one type of image, not one type of demonstration. And so we use the galleries as a basis for making a rather preliminary sorting of the types of image that are produced and what's done with them, what kind of work is being done with them promotionally and in terms of communication. Image galleries often don't say very much about the objects other than to give you an appreciation that they're very small. And that's very important, particularly for some of them. So let me run through some of the types. We've developed 5 types. You could do more. You could divide these up or collapse them. They're quite fluid in the way they operate. We'll start with what we're calling empirical renderings. Now, I don't want to suggest that these are not heavily worked over images, because it takes a lot of work to convert scanning tunneling or any other type of microscope image, electronic digital image, into a meaningful depiction. And computer programming and various artistic techniques or crafting of images are used. But the point here we're making is that there's a certain appearance of images where the claim about the image, and I don't doubt the claim really, is that they're drawn from data taken with an instrument. They are processed, cleaned up in certain ways, sometimes color-coded, but usually they're monochrome, right? Because there's no color at that level. The color here is a cast of sort of an orangey, yellowish light that's often used in depictions of scanning tunneling microscope images, but often they're black and white. And a phenomenon that's very ubiquitous in nanotechnology is called the nanotube. It's a single-walled or double-walled arrangement of various types of carbon molecule. And they're thought to be a possible structural or microelectron or molecular electronic structure. The appearance of these things can be deceptive. Kevin Kelly at Rice University, who shared this image with me, is concerned with how the visible properties of some of these things are generated by the relationship between the tip, and you have to kind of correct for that. But many displays in the galleries are quite different from showing data. Instead, they are in various ways demonstrations of what can be done. We call these displays of virtuosity. That is, often useless objects that don't have an immediate use, that are built sometimes frivolously, but often to demonstrate what the nanotechnologist, nano-artist can do with the tip of a probe. So, like the IBM, the website that the Almaden group has all sorts of inscriptions done with atoms on a surface. This sort of thing is a more chemical arrangement that is titled helium impressionism, because helium was one of the elements used in that display. This actually is a model, but of a chemical that a Rice University chemist named Jim Tour develops as a kind of playful thing to demonstrate the arts of chemistry to kids. So that the chemical model is arguably a depiction of the chemical he can make through manipulation by chemical means, and he has a whole series of these things that have kind of humanoid or animaloid features. And so all of these are showing things that can be done. They have no immediate function other than display of what the artist can do with the tip of the probe. Some of these displays of virtuosity are sculpture-like. This is not using the scanning tunneling microscope, but using laser or other light beams to carve shapes out of a matrix. And this particular product is non-functional, unlike the ready-made that Duchamp made, and I found this on the web where Mao Zedong was, I'm not sure he's admiring it, he's looking at it. So, but there is this playful but also demonstration of what could be done with the instruments evolved. Some of them are said to be functional. There's a Cornell scientist who his associates have made different generations of nano guitar, and they claim, I've not heard the music, that they can play the strings with laser beams or some other form of emitted energy. Other nano objects are found in the sense that they are not deliberately carved or shaped or manipulated, but are identified through the exploration of terrain that's produced through chemistry. There's a distinction used in nanotechnology that's between top-down, where a probe will be used to manipulate atoms directly, versus what they call bottom-up, where chemical means are used to produce whole fields of objects. And in those fields, sometimes there are discoveries of things that are selectively drawn out and sometimes colored or framed to look like familiar objects. And you'll find lots of these in nanoscale things. And they're kind of curiosities that are displayed in these websites that often evoked something familiar, like a bouquet of flowers or a mushroom in this case, that to appreciate them, of course, you need to know that they're not flowers or they're not a mushroom. They are something that is quite different from that, but it's the analogy between them that makes it exciting. And then the captions are very important. In one case, this is a contest winner. This mite loses fight with nano porcupine. You have to use a lot of imagination to know which one's the mite and which one's the porcupine. I guess the bigger one's the porcupine, but I'm not sure. And then landscapes also are abundant. This is from the Eigler website. Again, it's not exposed too well here, but the caption for this likens it to a Japanese garden. I see it to be more like a southwest U.S. or possibly a Martian landscape, but it really is a copper arrangement on a flat surface in surface science, but it's colored with a bright blue background and the red up front to give it that sense of landscape in the display. To go through, very often we find in nanoscale depictions that models are used but depicted in a realistic way. I've been emphasizing that often we see the devices of linear perspective, so a vanishing point here with a display of a carbon nanotube. And of course this is not taken with a microscope of any kind, because you can see they're color-coded, again evoking the familiar form of hand tools that were once widely used in chemistry. Now usually you find them in computer imaging and modeling. And so the model is used in a way that's depicted realistically to indicate that this is what a nanotube looks like, although no image of a nanotube would look exactly like this. It would be much more irregular. There would be defects. There would be, not this uniform kind of structure. The individual components would not be smoothed out like that. They would not be exposed, and of course they would not be color-coded in this way. And then there's another phenomenon, a carbon molecule they call it a buckyball, after Buckminster Fuller, who had the geodesic dome. Sometimes they call them fullerenes for the same reason, fullerene. And they're arranged with 60 carbon atoms in a kind of circular arrangement. And you can see the difference between one that's taken with a microscope, and these are constructs in a way, although the carbon forms in that pattern as a matter of course in chemistry. And so you can see the difference between the irregularity of the middle image, which is a scanning image, versus the ones on the right and left where chemical models are used, again, in a realistic fashion. They sometimes are artified. There's an artist, and he's also a scientist, named Chris Ewells, who has a whole series, a whole website, where he takes buckyballs and other phenomena like that and arranges them in landscapes where sometimes they're in outer space. Here it's in a watery domain, maybe evoking some sense of the Taj Mahal or the Sydney Opera House, something of that sort. Again, playful. There's no scientific research hinging on this, but you can see that there's this use of realistic depiction to depict something that will not withstand light. However, that kind of use of modeling to depict also comes into play in the analysis of chemical and nanotechnological products. A group that I've studied at Rice University is developing what they call nanocars. And these are circular forms like a buckyball and other similar sorts of arrangements. And then another chemical molecular arrangement for an axle. And in some of the recent editions, they even have a little engine that can be powered by a laser beam. You can see here, though, this is, of course, a prototype designed with arrows to show the direction of movement, that there's rotation on axles, and there's a gold or some other atom structure underneath it that it's rolling on, very clearly depicted as, almost like a toy in a toy shop. This particular image shows you that there's a microscopic field, scanning tunneling microscope image where, again, this is not exposed too well, but that you see these little arrangements. This one has about 4 of them that would be corresponding to the 4 wheels of the nanocar, and through various means, not just visualization, the argument is that the wheels turn on an axis, though you couldn't possibly see it with these microscopes. But that juxtaposition gives you a sense that this is drawn out from and also used to analyze the blurrier, less distinct empirical rendering. These kinds of imagery, where you have a molecular shape arranged in a way that evokes a mechanical technology, goes back to one of the kind of visionaries of nanotechnology, Eric Drexler, where when you go to the sites at which his models are depicted, you'll see that molecules or arrangements of atoms are used to show things like gear structures, classic forms of mechanism that would be arguably built through the manipulation of atoms. Drexler imagined you could do this atom by atom, or even get machines at that level to build other machines, and this was a vision that both excited and horrified people about 20 years ago. He was criticized very strongly for imagining things that could not possibly be built at that level, because the idea that you would take atoms and just sort of pop them together like this defied some of the quantum forces that would supposedly operate at that level. And so that kind of model of nanotechnology has fallen out of favor. However, built in a very different way, these machines, nanocars, that are the inheritance of Drexler's interlocutor, Richard Smalley, who died in the early 90s, or no, early 2000s, are evoking some of the same imagery. And even in biology, that kind of depiction of protein molecules arranged in a kind of gearing mechanism is used to describe the flagellum. Interestingly, an animation of this depiction is available on the website of a creationist or intelligent design scientist who uses this to document the argument that this machine is too complex to have evolved, and so it must have a designer, right? And showing the gear rotating and the flagellum waving away is part of an intelligent design argument, and that kind of mechanism is used to do that, to evoke the sense of design in atomic structure. Okay, the final group we're looking at, and we've already seen that first one there, are what we're calling fantastic Voyages images. These have been much discussed and much criticized by people who analyze nanoscience and nanotechnology. One very interesting article written by Bridget Nerlich likens some of these images, and there's a whole group of them archived by the Foresight Institute that Eric Drexler started, that they look like, they evoke the imagery of Jules Verne or Voyages of Discovery and science fiction types of imagery. So there's this sort of rocket ship-like thing here, or some sort of Death Star here, or in this case, blood cells are often used to depict this as Star Trek type of ship going through a blood vessel and perhaps cleaning out cholesterol or doing something useful like that. But again, depicted in a way where the machines are like plastic models, right? They're as if composed by the kind of material that we would be familiar with in macro scale technology, rather than being something that would be less stable, less hard surface, less reflective of light and that kind of thing. This kind of image, although they're still very popular, still very spectacular, have kind of fallen out of favor. And one analyst has used the monstrous term de-nanobotization to describe an era in more recent nanotechnology where the idea that these little robots would be the product of nanoscience is now on the wane. And so this idea nanobots would be little nanoscale robots, right? That now they're out of favor, and the promise of nanotechnology has gone to other things. Things like molecular junctions, new methods of chip manufacture, even things as mundane as clear sunscreens to reflect light off your skin without leaving a white surface. New fabrics, things of that sort, and this kind of fantastic machine has gone out of the way. So there's a lot of emphasis on future, both in nanoscience itself and in science studies and other accounts of nanoscale. But as I've been pointing out with this idea of making the strange familiar, very familiar types of artistic imagery and analogy are used when nanoscale is made available to the public, and to some extent made available to other scientists, so that recognizable objects, including fantasy objects, familiar science fiction themes, fields that look like landscapes and so forth, are used abundantly to make it intelligible. And it's been critiqued for that. I don't actually intend to critique it for that, because I think it's inevitable, at least at some level, that familiar imagery has to be used to make science available to people who aren't familiar with the deep theoretical and empirical work involved. But it's quite egregious in some cases of nano. So let me wind down with some First, some discussion points and then a few concluding remarks. These are things that, if you want, we could talk about later, and I'll give you some hints on where I stand on this. And this relates, I think, to issues of innovation, entrepreneurship perhaps. Was early nano oversold? That is, were these fantastic depictions, were these imaginaries of building mini machines and then depicting what they would look like, creating expectations about nano that have actually created some trouble for it. And much of the analytic writing about nano points to how both fears of machines out of control at the nanoscale, as well as fantasies of what that would mean for biology, for medicine, and so forth, proliferated in the early 80s. Michael Crichton's book Prey is an example of, it wasn't just about nanotechnology, but it was one of the examples of a fantasy of horror as well as of a future that came out of the early imaginings. I've pointed out that all of the types of image I showed you involve imagination in some way, but only that last group involves a kind of fantasy and imagination of completely freely depicting possibilities of a future that nowadays look less and less likely to even that we would ever approach. Although some elements of them have been picked up, as I said, in the nano cars and things of that sort. Now, part of the problem with critiquing this type of thing is that if we believe there's no pure description of something like the nanoscale, lots of different ways it could be described or depicted, then it's doubtful to say that one type of depiction is unrealistic fantasy and another is a more empirically grounded type of imagining. And so the question I'm leaving you with here, I'm not going to answer this, is how do these different types differ in a way that one would be an evoking imagination in a way that would be perhaps productive, realistic, whereas another seems to be quite misleading. And then related to that is, we can look at how imagination comes into play in different types of imaging, and I think it comes into play quite differently. And then related to that last point, there is this question of, okay, if we're going to say these images are distorted, we don't know what they're distorting exactly, because the baseline of nano is what's being envisioned, what's being brought into visibility for any kind of image, and there's no basis for a single type of imaging of it. Okay, so we can make some comparisons between the different types. I think even in the depictions of nanotubes through scanning tunneling and other types of scanning microscopes, it requires imagination because the images are quite limited in what they show. Their structure isn't brought out. Their chemical structure particularly has to be derived from blurry, partial, and not very well resolved images quite often. And so molecular models, although they are built, constructed, are a classic way in both biology and now in nano to derive structure from not only a single type of data, but many types of data. And it's going back and forth between models and images that I think is very interesting. One thing about that I think is quite interesting is that we often think of models as being derived from data, but a number of people who study visualization, particularly Natasha Myers, who's doing something on molecular models, points to how models actually provide a shape or provide an expectation for what things would look like. So since we don't know what a molecule should look like, should it look like a kid with built out of little balls, or should it look like a ribbon structure, that the existing models create a sense not only for how to think about molecular structures, but also when the flexible aspects of instruments are used, they start to look like that when they are developed. They can. That's not inevitable, but they can. The analogy between, or the visual analogy between nanocars and Drexlerian machines, I think, invites interesting issues, because the one is viewed as impossible, the other is something that's being developed by the very people who thought it was impossible. And I want to follow that one to see where it goes. I think it's an example of how something that's been discredited can sometimes be retrieved through another successful development. Okay. Displays of technical virtuosity show imagination of various types, sometimes just very playful uses of material, yet it also shows potential for production when harnessed to things like electronics. And then the found objects, the flowers and mushrooms and so forth, require a viewer to appreciate that the things are not what they appear to be, that they're selected from a level of scale. Whether that leads to anything productive is an open question. Perhaps once in a while it does, because of the play of imagination and the possibilities that open up. And then finally, the fantastic Voyage images, I think, are in some sense the least imaginative, even though they are the most overtly fantastic, because the way they're depicted, the kinds of macro-scale forms that are sort of displaced into the nano or somewhat larger than nanoscale domain are really not taking advantage of possibilities for developing means of visualization that would perhaps be more adequate to the phenomena. Okay, so I think it's important to keep in mind that galleries are a very special object. They're not indicative of the research front, whatever might be meant by that. They are definitely part of promotion, innovation, and play. I think they're very much part of play. And so they feed into innovation, but perhaps not something you would see. You wouldn't see these images necessarily being used in a serious way in research articles. Once in a while they are, but not often. And then, as I've said, I don't think I need to belabor that point anymore, but I think that many images in the galleries very overtly make use of familiar themes and things. I think that also applies to many other types of visualization, both in research and in promotion. Looking at it that way is a way of sort of drawing back from the idea of thinking of nano as being totally new, totally unprecedented, and we often think of technology that way as, being something completely new. We emphasize the new. We don't look at how the familiar is part of that. As I said before about chemical models, idealizations can provide templates for realization, and I think that's an interesting thing to follow in a field like this. But again, as I've said, the most fantastic are in some ways the most conservative in the way they use conventional modes of depiction. So let me leave with a question. What are the implications for imagining innovation? There's one in the back there. Please.
Thank you so much. Maybe more comment than question. Just one interesting parallel came to my mind when you mentioned that actually idealized images can influence the empirical investigations. I remembered of the kind of images we see in sound editing programs, in sound editing software. Sound engineers sometimes just look at the wave and they see an image that something is wrong with the sound. But the scale to which you may go into details of sound is even more detailed than if you just hear. Sorry if I'm not clear. But actually, they try to figure out what's wrong with the sound using image, not the hearing. So, in this case, also we see as imaging something which is not visual, ontologically. Just influences the way how it is treated afterwards.
That's very interesting. It's like, you know, text. We don't think of text as an image of voice, but it takes on a life of its own, right? And visualizing sound in that way also creates visual phenomena that become features of sound. That's a very interesting example.
So thanks a lot, and plenty of questions, but let's focus on the most stupid one. Can we consider atom as an object? Because every time when we make something strange familiar, something very familiar becomes very strange. This the very notion of materiality and objectivity is under question now, because whatever theory of materiality we take, Victorian idea of object from to object, or Garfinkel's idea of oriented objects or as of which objects, they're not applicable. They don't seem to be applicable to this very action.
Okay, why?
It does not exist. Atom is something that you can depict and actually show that you can do this in many different ways. And that's and also because as soon as there's an important mechanical materiality is any sociological definition of object, how can we define atom? Because it doesn't look like we can easily define atom in the way as we define the everyday things.
Okay. I think I understand your question. It's an interesting question. It's not a stupid question at all. I guess the way I look at it is this way, and this may be a stupid way of looking at atoms, I don't know, that atoms become everyday objects insofar as they are turned into reified pictures, whether it's, you know, the Bohr's model or some more recent cloud-like statistical thing, that conventionalizing them does give them and naming them, building the names and the pictures and the references to them into a greater number of familiar contexts, gives them an object status that is maybe not as stable as some others, but they have a kind of everydayness through that. An example of that is Alberto Cambrosio and some colleagues of his did a wonderful paper about 20 years ago about antibodies. And the first depictions of antibodies were explicitly conventional, like cartoons or something, that because there was no way of knowing what an antibody would look like. And there was even debate about whether it should be depicted at all. But then, as these conventions for depicting them developed, antibodies took on that form. Not necessarily that that exhausts all about them, but that they, being named, being characterized, being structurally characterized, gives them an identity that I think can both close off research as well as open it up. I mean, it closes off possibilities that may require a different mode of realization than those kinds of depictions, but at the same time, they are giving them names, forms, identities, structures that are very object-like.
General thrust of the presentation, if there is one. And many people in the audience have read Lacan. And of course, would you see, Victor's point was also pretty much driving in that direction, I think. Would you see your presentation as somehow assaulting one of the main tenets of laboratory life, and Science in Action that science is all about visualization devices. Because of course Bruno would talk about, bubble chambers, spectrometers, chromatographs, and they're all kind of representative devices. Now, of course, nano-level representations, they're not representations at all, they're manipulations, as you're telling us. They're poking, right? Poking stuff, devices. So that means that right now, either Latour's claim that you don't have visualization device, you don't have science, it basically was completely subverted, or this is a new type of visualization which arrives in. Where do you see it?
Okay. Well, Bruno is notorious, and he says this himself, for changing, right? So I haven't finished it, but I was reading an article about maps that he and some colleagues used, and they're very fascinated with maps that are deeply interactive, that can turn into not only landscapes, but with devices like, they can take you to the ground, right? And you can see the ground floor of places, and it's that possibility he sees as very interesting for maps. And those are not representations in a familiar sense, right? There's not that sense of stability, immutability that would be available in an older form of map. So it's very hard to, this is one of the things that makes him fascinating. It's very hard to pin Bruno down to a particular concept that you can then critique. I think that this issue of manipulation is very interesting insofar as it does demonstrate a level of intervention in the phenomena that any idea of representation doesn't quite capture. And Peter Gallison and Lorraine Danson and Peter Gallison, in their book on objectivity, make quite a lot of what they call presentational artifacts through nanotechnology. And they talk about haptic. I don't know if that's a familiar word, but the idea that you are feeling and moving and directly in contact with the reality that you are in touch with. I think that is a very interesting possibility. I don't think it's novel to nanotechnology. I think you find it in surgery. My colleague Rachel Prentice is writing a book, or almost finished, it's almost published, on haptic relationships in surgery. I think it's available in some other fields, but it's certainly spectacular in some areas of nano. It doesn't exhaust nano. A lot of nano is chemistry, right, that produces phenomena through, it's a kind of intervention, but not this direct manipulation you get. So I don't know, I don't think there's an easy contradiction with Latour. It's always nice to try to criticize him because he's on the scene, and he establishes so much that people talk about and think about, but especially with more recent work, I think he's flexible enough that he could take this on without too much trouble.
Well, thank you. Anna, for the question.
Yeah, I have a same question. I was remembering work of Contentious, and she was writing about working with particles in high energy physics.
Mm-hmm.
And she was trying to make this really direct line between molecular biology and physics through exploring the way how these sciences work in this object.
Mm-hmm.
And if we're trying to do the same work with nanotechnology, can we say that nanotechnology is some does it provide some specific, first of all, does it provide some specific scenario for users, and does it provide some specific scenario for scientists? Like, does it create some specific epistemic culture or something like that?
Oh, okay. Very good question. One problem with thinking about nanotechnology with epistemic culture is that it's so diverse, right? That in some sense it's a movement led by large institutions to collapse epistemic cultures in the way that Norsetina describes them, you know, or at least to get them to relate to one another, right? Because at least when you think of nanoscience as a broad scale movement, it's no single way of working. It's no single type of culture. And it involves collaborations across very interesting divisions like medicine and material science. The collaborations are partial, right? People don't give up their fields and do something else. They're often mediated by postdoctoral students or doctoral students who, you know, are transmit stuff back and forth between labs. And it's also an identity that is very partial. So for instance, if you take somebody who works in chemistry or material science, you say, are you a nanotechnologist? And I don't do surveys, but I think if you were to do a survey, and people have done surveys like this, many of them will say, well, I'm not really a nanotechnologist, don't even know what that means. What I am is a chemist. And I work on nanoscale phenomena, maybe get money from National Science Foundation Nano Initiative, but it's not a deep cultural identification for those people. They're still committed to chemistry, and they do nanoscale as part of a partial identification with that kind of entity.
You told us more about the visual than the temporal. So the futures was the beginning and the end, but the classification was more the different modes of these different ways of imagining. So, and some of these ways of imagining the nanoscale do not seem to entail.
I'm sorry.
They do not seem to entail very different futures. Sometimes they actually, some of these fantastical voyages, they do. But some of them seems to be sort of neutral in terms of the futures that they offer. So if you see, and so if we went to this really stupid exercise of relating the varieties of features that the nano world is trying to promote and this classification of images. Would you cross, what would happen if you wanted to cross that?
Okay.
And also, is there a relation between these different images, different ways of imagining that level, that scale, and the fact that there is a very elusive reference? A very elusive reference, that it's messy, and people who are criticizing the imaging of that level, that scale, say it's so messy, we can't claim control of that.
Okay.
That domain.
Yeah. There's a lot to your question. I'll try addressing a few things. I think the most obvious imagining of the future is this last and earliest phase of nano images, where they depict some fantasy of, science fiction type fantasy. The other modes of imagining have a future horizon, like for instance, a model of even something as ubiquitous as a nanotube portrays a perfected structure that, as an engineering matter, some nanotechnologists will try to realize. There's a chemical, I guess you'd call it a chemical, atomic structure called graphene, which is a single layer of graphite, right? That in a conference I attended, a number of speakers spoke of graphite as the perfect substance, right? So there's this sense of realizing perfection in terms of almost a mathematical tiling configuration, right? And it looks like mathematical tiling, a perfect, indefinitely expanding arrangement. And some of the speakers at the conference were talking about how their companies, their research institutes were often funded by companies also located at universities, were expanding the extent to which they could make perfect graphene that would not have imperfections, would not have holes, would not have anomalies of certain sorts. There also were some interests in imperfections as also establishing electrical properties that could be quite useful, but this idea that the kind of mathematical, geometrical perfection that the model embodies could be a goal for research and development in a kind of a normal science, if you like, does point to a future, right? It doesn't indicate something that's completely beyond the capacities of current technology to do, but it points to something that incrementally can be approached, perhaps never fully approached, but incrementally approached through the perfection of that art. Similarly, some of these displays of virtuosity provide sort of metrics for what would, say, go to a smaller level of scale, a finer grain of activity or of construction than previously done, so that kind of material pursuit can be tracked through the competitive displays of what instruments and technologists can do. So I think they're different futures, right? I think they're different ways of imagining or indicating or implicating a future, but in some ways, in very different ways than this, fantasy depiction of something that can be freely imagined and painted in an image. There was a second part of your question, though. What was it?
We could keep it also about, but the second part was these ways of imagining and these ways of creating different futures, are they related to the illusiveness of the record?
That it could lead to?
Illusiveness, the fact that we are actually exploring the wild, and so the fact that we are exploring the
Yeah, one thing I wanted to say about that I didn't mention in the talk, which may be beyond my capacities with physics and chemistry to get a good handle on, which is that even if you look at a poster in a poster display or hung on a wall outside a laboratory, there are multiple machines, instruments, multiple forms of representation used, some involving equations, some measures, spectroscopy, scanning tunneling microscopy, and it's the working among those modes of visualization, modes of measurement, modes of analysis, that something like a model of a nanocar comes out, right? They aren't just looking at an image and then inferring from that a structure. They're doing various other kinds of measures, also doing stuff in time lapse and other forms of multiple image production that together are synthesized in a model or in a description. And that's very hard to track because it involves skills of many kinds that are collaboratively produced, and it's also very technical, beyond my capacities to trace. But I think I can say pretty confidently that that's where a lot of the work is done. It's not done in terms of going between images and models and back to images. That's a kind of simple way to talk about it that works for some cases, but that more complex multi-modal work is, I think, where much of the work is done.
At the beginning of your lecture, you showed was a letter that was written in very small scale and it was projected to the years 2000. With your current knowledge of the rate of technology and the debate, could you sketch the debate
that will be going on 2050, or sketch what kind of problems will be solved that you already mentioned. We could a little bit at the future, taking the rate of technology into account.
No, the easy answer is no, no way. Yeah, I think that it would be, well, I think I can say this confidently, that the depictions of spaceships or rocket ships or submarines in blood vessels are a way of envisioning possibilities that would be done by other means. So I see it as quite possible that all sorts of medical innovations would come out of nano research, but they wouldn't look like that, right? They're increasingly diverging from looking like that, right? Little robots, little self-acting machines that would scrub your blood vessels. Instead, it seems more likely that connections between fluorescent dyes and nanomaterials, nanoparticles, would allow for the tracing of the movements of blood, the location of blockages. And then perhaps there would be, of course, refinements of tools that would go to those. But I don't think you're going to find little self-acting robotic machines. I don't see anybody developing that. The nano cars, I think, are intriguing, but I don't think they're going that way. They still need an external source of energy to drive them. And, you know, maybe I'm wrong, and Jim Tours and his group will have little race cars going around on surfaces in the future, but I don't see too much going in the direction of like the, you know, nanoscale things that look like macro scale tools and machines.
I have two, sort of empirical question and a more speculative one. The first empirical question is related to what you were saying to us, this idea that there's actually different kinds of outputs of the microscopes and of the different measuring instruments that are used. And one of the ideas is that because these kinds of images that you show are actually very limited kind of image, because it's two-dimensional, rather small, they fit in one page. So there's this sort of clear specificity of these kinds of images where you can imagine long, computer outputs of numbers saying what the microscope actually saw, which could be one of the first stages of the results. But then there's also more than that, which is that it probably moves, because if at this scale everything is so stable and something, there's probably movement. So I was wondering about these things like list of numbers and the kinds of other specific like visualization techniques for these kinds of numbers. Is it just spreadsheet stuff, or is there something specific to try to dig into that, for instance? The other thing is, are there videos, for instance? Is there film, like moving image? Because, and that relates to the second empirical question, which is the idea that maybe one of the reasons would be that this kind of representation has specific purposes, and the question of like, why are they here? Because I suspect they do have a cost, for instance, or maybe they're just a byproduct of observation and the use of these machines. The question is, why are they circulated? Is it for fun because there's a sort of geeky community of people who actually have fun doing this? Or do they also want to, I don't know, generate goodwill and funding, possibly from government bodies or something, by making a big thing or presenting a visible, etc.? There's this sort of empirical question about the economy, basically, what are the cost and benefits in the way?
Yeah, good question. Series of questions. Let me address the last one first, because that's the one I can remember the most. Definitely, the issue of funding is important, and some of these now discredited images that, like the nano louse, will show up in press. One I remember from a couple of years ago, Rice University was announcing a nano discovery about a medical application of nanoparticles, and they had a picture of nano louse on the press release, right? So that because it's a spectacular picture, immediately attention-grabbing. It was juxtaposed to something completely divorced from that kind of technology. And so they do have a ubiquity, and they do have a hold on naive imagination, mine as well as members of Congress, presumably. And at least until now, nanoscience in the U.S. has been very successful at getting government initiatives. A few years ago, there was one of many budget-cutting operations at NSF, but they didn't touch nano. Nano went up, a lot of other things went down, and there was a lot of appeal. I think that the appeal can't be contained in images. I think the images are part of a larger campaign, the campaign being promises of technologies that would have multiple payoffs, like in electronics, fuel cells of a different type, the successor to silicon, medical applications of all sorts, new fabrics and these sorts of things as potential, and to some extent partially realized benefits from it. And images actually don't really, these images I showed you don't really promise those sorts of things. And I think that they are passing away because as nano develops products and develops momentum and gets a history of its own, if it succeeds, it will fly on its own success. Some people tell me, I don't know how to verify this, that nano is already becoming passé, that synthetic biology is the next wave, right? So we shall see. I don't know. Yeah, was it? Yeah. Oh, was it? New Yorker. I missed that one. I get that. Yeah. Oh, there was more to your question, though.
Well, the first one was actually sort of crackle. It's about the films and so on, like, why is it just stable images? But the speculative comments would be on the fact that actually if there's a parallel that comes to mind, it's with accounting, actually. If you want to, this kind of visualization is quite close to accounting, because accounting is definitely one of these kinds of ways to make things visible and present images in the form of tables and sometimes actually photos and things that actually also probe into, because accounting is also used for the daily management of and getting the numbers actually has an effect on the companies and so on. And in a way, there is a sort of very sort of strong parallel between the two, and also for this gathering funding and so on. So in terms of this kind of visualization that is also making up things because they're very much thinking about creating the company as an entity and so on. So I was just, it's very speculative, but in a way there are some
Oh, I see.
parallels.
Yeah, interesting.
Let me get back to this. I'll have to stop at some point and I will have time to answer you, how to ask you my questions.
Okay.
And actually I'm also playing on parallels everybody takes from their own background. Tan comes from the Department of Accounting, so accounting is there. You're in the country of the icons, so I'll finish with the icons, but I'll start first with, I have two questions, and they're related. It's all this kind of contrast between the visibility, which is objective, kind of representative visibility of bubble chambers and spectrometers to which we are accustomed to, and a new kind of groping, poking, haptic visibility, which Destin and Gallison articulated, and which you once again referred us to in your presentation. The first question is, to what extent, like the classical microscope of, I don't know how to pronounce that in classical English, in Russian this is Huygens.
Oh, okay.
The guy who invented the microscope, right?
Yeah, Huygens or Leeuwenhoek, yeah.
To what extent this was not a haptic technology? Poking, I mean, I can imagine you can provide a description, but the first one were actually not precise enough. You have to refocus them, to take a look left, to take a look right before you saw the real bacteria. And also, by the time they were constructed, Spinoza was ruling the day, and Spinoza is all about the eye as being a projectile. It's not about something coming into your brain, but rather it's about the body flowing contours, other bodies, eyes groping out there, getting something inside. So that's the first, to what extent there is this difference between the objective representational technologies and the haptic ones.
Yeah.
The second one is that what I see in your pictures very often, I would provide so much enthusiasm about nano images, is not that they evoke media craze, but rather what the non-representative images should be doing. And in Russia, we know what non-representative images are doing because they're called icons. The main point is very simple. They have to produce prosternation. They have to produce awe. They are stairways to heaven. You know? You stand in front of the icon, you're not looking at something. It's God which is looking at you. And they are functioning like the icon on the computer screen. You hit it, you're going straight to God. And the point with it may be that actually your images, they have this prosternation component in the sense they immediately get you partake in something bigger. You think you're poking and sensing out, but in a sense, the whole power of that stuff is that it gives you a religious dimension, which the usual spectrometers, you know, all the kind of bubble chamber stuff, it might have it somewhere deeply buried in them, but they really cover them up. While the new visualization technologies, they bring this non-representational mechanisms into the forefront. And that's why they have this wide appeal. It's not fantasies, you know, it's not kind of computer games. It's basically wow. And this wow, if it has a bit of fear and trembling, that gets you right.
Well, that's a very interesting point. I have to remember the theme of prosternation as a possible, not function, but relation that is produced by some of these images. Certainly some of these images do, particularly the most popular ones, do aim for awing an audience and attracting their attention. And of course, drawing upon familiar scenarios from fiction and fantasy is a way to do that. So I may be belittling their awesome potential when I point to their fading presence in the field, but they certainly did have and still do have you know, quite an evocative presence. First part of your question though was
whether the distinction between haptic and classical.
Yes. Yeah, I've never been. You know, that chapter in Gallison and Daston's book is their last chapter, and probably by their own reckoning, their weakest, because it's not really their historical work they're relying on. And I, like you, I was led to question this emphasis they put on haptic objectivity as being the new 21st century era, because as you say, with light microscopy and electron microscopy, there's a great deal of preparation that goes into the visualization of the specimen. However, it's done temporally somewhat differently, right? It's like the specimen is prepared for visualization. It's photographed or viewed in a separate phase of action. With this haptic manipulation, the phenomena is being constructed and visualized not exactly simultaneously, but in very close order. So there is perhaps a difference there. And certainly it's not at least with some of the instruments, it's not a question of feeling the object, although there can be dexterity involved. But I think you will find that although nano provides a very clear case, at least some aspects of nano and instrumentation provide a very clear case of that, it can recall how in other, even very old types of technology use, that comes into play as well.
There's space for another question.
Nope.
Thank you so much for your extremely interesting and encouraging presentation dealing with the question of visualization. I would like to know much more about your vision of the role of visual visuality within the field of sociological research. Do you see any visual term within this field? So how you see avenues of possible research within the sociological in general?
Oh, well, there's different types of visualization in sociology. What I'm doing is taking visuals from a field and treating them as analytically, right? So that they're not necessarily well, they are and they aren't my demonstration devices. I think more commonly in sociology you find, of course, graphics, and you find some illustrative pictures sometimes. But there is not a very deep visual culture in sociology. I once wrote a very playful article called Pictures of Nothing with a question mark that was about the diagrams used in social theory. And we don't have a oh yeah, we have a whiteboard. The diagrams in social theory often look like this. Bad chalk here. So you get society, science, technology, society, right? So you get something like that, right, as a visual, right? And from my editing work, I was led to wonder that very often when you want to save space in an article, you'd say, well, you don't really need this diagram, do you? You could say, well, science, technology, and society are interrelated. All right, and then erase it, right? So what you don't find very often in sociology is, certainly with mathematical graphs for statistical articles, I think that they're fairly indispensable, but for that type of article. But for conceptual diagrams, you don't often find that they do much work, right? That you don't turn to them and say, now I see what that could be talking about. It's instead just another surface to say the same thing. And I don't want to blame sociologists for that, because I think it's not as though you could like sit down and think of a clever way to use diagrammatic or pictorial conventions in sociology. I think it goes more deep into the subject matter and the history of the discipline. And maybe somebody brilliant will come along and devise a way to turn sociology into a visual discipline. But you just don't find the kind of rich imagery in, I think, any of the fields of social science. Except, I'm cheating, right? I'm using other people's imagery. And I can comment on it and compare it and do those sorts of things. But I'm not generating novel imagery that would be distinctive to sociology and would be our kind of mode of presenting. And the little bit I've done on that didn't really deeply go into why that's the case in sociology, but I think it would be very interesting to explore that.
Very short one.
Okay.
What's interesting about this different sources of imagery, because of course the most common one we know is about dual spiral of DNA. This one represents stands for like all chemical.
That's an icon. DNA, the double helixes. Yeah.
Chemistry is the best thing for fundraising, because
Yeah.
not everyone knows why they're paying for this dual spiral.
Mm-hmm.
But it doesn't look like nanotechnology has any emblematic images that we sell right now. And the other thing that really puzzles me here is that all new metaphorical ways of transposition, like keying another vocabulary description to another object, they always imply some kind of image observer. For example, those new mega worlds, like 4 for imagining planets and planetary systems, there's always something like a rocket or a guy on the rocket who is watching this. It's somehow implicitly always involved some kind of figure of observer who is doing this kind of observation. And who's not an observer is not one, because it's definitely not this guy, right? Not that one. So is there any iconic or any figure of observer that is
Actually, I didn't ask. It reminds me, I didn't really address the question of moving images in nano. That came up in an earlier question, and that kind of implicates the notion of the observer, because the flat, perspectival image implicates, the fixed point observer of the Renaissance. But there are also popular images that show fly-through of nanotubes and so forth, where they use cartoons. But there are also, I've seen some demonstrations of time-lapse and moving images that show changes in a field that are important for research. And so dynamic interactive kinds of imagery is starting to come into play, and certainly with computer imaging and web storage, it's likely to become more commonplace. Whether that implicates an observer any differently than, say, the static relationships between object and image, or observer and image, or observer and object, is hard to say, because even in a moving image, there's still an observer moving through a field, and so that there's not a radical difference there. I think many. I didn't mention this, but many nano labs or nano facilities, centers, have artists in residence, and I think that the hope is that the artists will come up with novel modes of visualization. From what I understand, I haven't really looked into it in much depth. Many of the artists do what artists do, and the scientists do what the scientists do, and there's not a whole lot of really productive interchange, but they have some fun together. But I think the hope is that there would be some discovery of novel ways of reconfiguring those relationships. Thank you.